going to discuss graphs of equations and circles. Finding intercepts. To find any x-intercept, that is where a graph crosses or touches the x-axis, we set y equal to 0 in the equation and then solve for x. Similarly, to find any y-intercepts, that is where a graph crosses or touches the y-axis, we set the x equal to 0 in an equation and then solve for y. For example, if we want to find any x-intercepts and y-intercepts of the graph of y equals x squared minus 5x minus 14, then for any x-intercepts, we set y equal to 0. X squared minus 5x minus 14 now equals 0. We set y equal to 0. We want to solve for x, so we factor x minus 7, x plus 2 equals 0. This means either x minus 7 equals 0 or x plus 2 equals 0. If x minus 7 equals 0, then we add 7 to both sides and x equals 7. If x plus 2 equals 0, then we subtract 2 from both sides and x equals negative 2. Therefore, the x-intercepts are 7 and negative 2. To find any y-intercepts, we set x equal to 0 in the equation. So we have y equals 0 squared minus 5 times 0 minus 14, which is negative 14. Next, we discuss symmetry of an equation. We say a graph is symmetric with respect to the y-axis if both points xy and negative xy are on the graph. Here is an example. This is the parabola y equal x squared. Notice that the point xy and negative xy is on the graph of y equals x squared. Notice also that the line that joins these 2 points is horizontal. It's parallel to the x-axis. Now, a graph is symmetric with respect to the origin if both points xy and negative x, negative y are on the graph. In this case, we see both xy and negative x, negative y are on the graph. This is the graph of the equation y equals x cubed. For example, let's test the equation 3x squared minus 2y equals 25 for symmetry. Let's check on symmetry with respect to the x-axis. We replace y with negative y into the original equation. So here we have 3x squared minus 2 negative y equals 24. 3x squared, well, a negative times a negative is positive, equals 24. Since replacing y with negative y produces a different equation, notice this is different from that one. This equation is not symmetric about the x-axis. Let's check about the y-axis. To check symmetry with respect to the y-axis, we replace x with negative x in the original equation. The original equation is 3x squared minus 2y equals 25. We replace x with negative x here, so it's negative x quantity squared. 3x squared minus 2y equals 25. This is exactly equivalent to the original equation. Since replacing x with negative x produces the same equation, this equation is symmetric about the y-axis. Next, we're going to test the same equation for symmetry about the origin by replacing the y with a negative y and replacing the x with a negative x. 3x squared minus 2y equals 25. In place of x, we put in negative x and its quantity squared. In place of the y, we put in negative y. So negative x squared is x. This is 3x squared plus 2y equals 25. Now look, this equation is not equivalent to this equation. Therefore, since replacing y with negative y and replacing x with negative x produces a different equation, the equation is not symmetric about the origin. Now we're going to talk about circles. The standard form for the equation of a circle with radius r and center hk is x minus h quantity squared plus y minus k quantity squared, and it equals r squared. The x-coordinate for the center of a circle is h. The y-coordinate for the center of a circle is k. Now here's an example. If we want to find the center and radius of a circle given in general form for this equation here, then what we want to do, we collect the x's together plus blank and the y's together plus blank, which equals 5 plus blank plus blank. Now what are we doing? We're going to complete the square here, and we're going to complete the square here. When we complete the square here, we're going to add a constant here, and we'll add a constant here. Since we're adding two constants on the left-hand side of this equation, we will add the same two constants on the right-hand side of the equation. Now the trick for completing the square of the x's, you take the middle coefficient, divide by 2, and square it. The negative 4 divided by 2 is squared. Negative 4 divided by 2 is negative 2, and he's going to be squared. So we put negative 2 quantity squared here. Similarly for the y, 8 divided by 2 is 4 quantity squared. We put it here. Since we're adding 4 and 16 on the left-hand side, we add 4 and 16 on the right-hand side. So now the equation looks like this. And we know that this is equivalent to the square of x minus 2, and this is equivalent to the square of y plus 4, and this is 25. So now we have the equation of the circle. The center is 2 minus 4, and the radius is 5. This is the graph of our circle. Notice the center is 2, negative 4. The radius is 5. This is the x-axis, this is the y-axis. To identify the point here on the circle, first we see that since the radius is 5 and the center is 2, 2 plus 5 is 7. The x-coordinate of this point is 7. Notice this line is parallel to the x-axis, so the y-coordinate is the same as negative 4. Therefore, this point on the circle is 7, negative 4.